Hi everyone, my name is Nihansu. I'm a fourth-year molecular biology and genetics student, and this is my Physics 102 experiment presentation. So for the experiment, my topic is changing the capacitance of parallel capacitors in different experimental setups. So let's start with what is capacitance. Capacitance is the ability to store electrical charge. It can be seen in things like capacitors, and the capacitance can be measured by C equals E multiplied by A divided by D, which C shows the capacitance, E shows the permittivity of the dielectric material, A is the area, and D is the distance. So in my experiment, I change these parameters and observe their effect on the capacitance. Also, since I use different materials between the parallel plates, to calculate the permittivity of the dielectric material, I use my formula 2, which is the multiplication of permittivity of free vacuum and relative permittivity. The relative permittivity is the difference or relative of our permittivity of the dielectric material compared to the permittivity of the free vacuum. So, and I use error percentage to calculate my experimental value and theoretical value differences. This is my experimental setup. I have three different parallel capacitors and styrofoam, the plate to stable the capacitors, paper stack, and an altimeter. So in part A, I kept the distance between the parallel plates in 2 centimeters and used 3 different capacitors that they have different areas, which you can see from the table, and plotted them in this table and calculated error percentages. So in part B, I kept the area constant and use only the capacitor that has a 10 centimeter in one length, and change the distance between them. I use 2 centimeter, 4 centimeter, and 6 centimeters for the distance between the parallel plates. And for part C, I changed the dielectric material between the parallel plates. First I use air, then styrofoam, and paper stack. So for the data analysis, I have 3 graphs. So this graph shows that the capacitance is a linear relationship between 1 over D, and their slope gives us the multiplication of permittivity of the dielectric material and the area. And by dividing by the area, since it's constant, we can find the permittivity of the dielectric material of the air, which in this case, the second graph is this one, which shows the permittivity of the dielectric materials. And from here, we can find from the slope that A over D is constant, and increasing the permittivity of the dielectric material increases the capacitance. And finally, in this graph, which shows the capacitance versus area, increasing the area increases the capacitance, and their slope again gives the dielectric material, permittivity of the dielectric material divided by D. So since D is constant, we can find the permittivity of the dielectric material, which is air in this case. So for the errors, one of the problems can be the fringing effect. Also, the capacitors and the platform to secure them, so maybe the distance between them is not, for example, 2 centimeters but 2.2, or the area can be different. And in one case we secure them on the styrofoam, so the bottom of them actually has the styrofoam instead of air in those cases, and I use a tie to bring them together so the cables don't tilt them. So these are all could affect the error rate. Thank you for listening.